Solar power, what can it do? It's either going to augment, it's going to meet your station needs, or it's going to exceed. You're actually going to be able to help some of the other emergency workers keep their cell phones, their tablets still going. Now, when you think about solar panel, you're thinking, oh my, you know, I checked on that a few years back and those prices were way too high. They were really high. They were about $5 or so a watt. But look at the pricing now. So in 75 it was $101 a watt, 77. And by the way, those panels are still producing power. Solar panels have a lot of longevity. The first ones were called monocrystalline. Now, the price that you're seeing per watt is the large grid tie. That is not the off-grid solar panel that we would be working with. So the Renogy 100 watt panel, that's this one right here. That's the panel that you're seeing, so I want you to see from what you had on the TV screen or the video screen. That'll cost you about $128. It'll give you 5.5 amps in full sun. You can have a lot of joy with 5.5 amps. Each solar cell, now, I'm going to take this 40 watt solar panel. This is an older panel. Now what you'll see is these are the individual solar cells. Maybe I can come over here. Can you see me okay? So these are the individual cells, and the off-grid solar panels were 36 cell panels. If there's about 0.5 to 0.6 volts, that gives you about, per cell, wired in series, gives you about 18 volts. So you have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 36. Now, the size of the solar cell determines the amperage. The bigger the solar cell, more amperage. The smaller, less amperage. Okay, the grid tie solar panels, along came the need for grid tie, and so we had to kind of keep our voltage around 18 volts maximum power. But the grid tie says, we're not charging batteries, we're going DC to AC, so they added more cells to get more voltage. So the amps isn't that much higher on the grid ties, they just have a lot more cells added, so you have a higher voltage. So you have 60 cell, 72, and 96 cell panels. So I was just doing some measurements here. So that's showing about what the measurement is there. And I'll have to just wait for a moment. This is actually two 60 watt panels. I'm measuring the size of the solar cell, the individual cell, on the BioEnerPower 120 watt solar panel, which is really nice. And then this is the size for this panel here. Okay, so how does sunlight charge my battery? So we use these photons of light, and there's a spectrum of light. There's this low energy infrared, there's the middle energy visible light, and then there's the high energy ultraviolet light. And the solar panel has to have a certain wavelength of light that it can use. So sunlight striking the earth has about 1,000 watts per square meter. On the wall, there's a square meter. So if there was a way that I could harvest all the sunlight energy, I would get 1,000 watts per square meter. And that's based on a mid-latitude city years ago in the United States, full sun at sea level. So it's just an approximation. It's not an exact number. It's just a number that we use that in full sun you're going to probably, it has the equivalent of about 1,000 watts per square meter. Now, we're interested in a photon of light. So that photon of light has a certain amount of energy. And I've got these silicon atoms, and I got these electrons, and my shell is half filled. And I dope it with some stuff. I don't have a lot of time. But basically, this photon of light, one photon hits one electron. that's just busy spinning around in its orbit and knocks it out far enough to get to what I'm going to call the electron highway. It's a conduction band. And the difference is a band gap. So for silicon, you need about 1.11 electron volts. Don't want to get too technical. And you don't want to go over about 3 electron volts. So if I have too much energy, that ultraviolet light, it's going to make heat, and it's going to pop the electron too far. But there's some things that happen. I can't go into much detail. But basically, if I can take that orbital electron, energize it enough to get to a conduction band, then it can go through and do power, and power our circuits. So there's this band gap. The wavelength is about 380 to 750 nanometers. And it bumps that one electron out of its orbit, and then it takes off through the conduction band. Now, sunlight is about 52 to 54% infrared, 42 to 43% visible, and a little bit is ultraviolet. And that's the real high energy stuff there. And our solar panels want this range. So what I did on this slide is I kind of showed the wavelength of infrared, visible, and ultraviolet. And our solar panels want about 380 to 750 nanometers. That's where it makes the power. So we use the visible light and a little bit of infrared and a little bit of ultraviolet. Now, the cells that we counted, these are the early solar panels. This is an older panel, and it still puts out its rated power. It's pretty amazing. 36 cells. Now, there was a time when some manufacturers said, oh, we don't want to worry about charge controllers. We're going to put 32 cells. We won't have to have as much voltage. Well, a solar panel drops quite a bit on the voltage the hotter they get. So we make sure there's enough cells wired in series to compensate. So here is the solar panel nameplate. And you'll find that on the back of your solar panels. And this is a 100-watt panel, and it has something called open circuit voltage. That's if I put the panel in light, and I take my volt-ohm meter, set it to DC, I connect the positive and the negative. That means how much the voltage is, the differential potential, but it's not under load. So it's going to be a higher voltage. And then as soon as I introduce a load, I introduce resistance. And then it's going to come down to an operating voltage. Okay, so watts is amps times volts. So for a typical 100-watt panel, they're taking the maximum power amps times the maximum power volts, and that makes your 100-watt panel. So the optimum operating voltage around 17.8 volts, optimum current around 5.62 amps. Now every solar panel goes through a test, a flash test, where they have the opportunity to know what the true output is. They'll manufacture them exactly the same, but there's a little bit of a differential that happens. So it's called standard test conditions. And the variation can be about 5 to 6% from the same batch. Now they look at the air temp in the factory. The air temp and the panel temp are at 25 degrees Celsius. And they flash it with that 1,000 watts per square meter intensity. And then there's something called an air mass of 1.5. I'll talk about that in a moment. So the irradiance I was mentioning earlier, where they got that 1,000 watts per square meter, was a benchmark that was set back years ago because we really were part of the drivers with solar panels in production years ago. So I'm just talking about the intensity. Your intensity might be around 800 watts per square meter. Now the irradiance, the intensity, affects amperage quite a bit, but it doesn't have as high of impact on the voltage. Now the AM 1.5, what's that about? If I'm looking straight up 1 atmosphere, that's AM 1.0, and I come down a ways, I get to what's called 1.5, and that's if I came down 48 degrees. So I'm going through more atmosphere, and it's looking at trying to simulate real conditions to a point, but it doesn't simulate temperature very well. And AM 1.5 takes into account the losses at that angle that the sun has to travel through. Now here's some sun angles. Basically, it's looking at air mass and then what happens with wattage. I won't have time to go a lot into that, but you can look at that. So we have the open circuit voltage. That's the big V and the little OC. And then in current, they use the capital letter I. So the short circuit amperage. And there's actually another type of solar power rating that California said, hey, STT, standard test conditions, really is not applicable to what true real world conditions are. And customers are going out and buying stuff and finding out they're not getting what they thought. Let's make it more real. And then they're talking about sun hour. So open circuit voltage, like I was saying before, that's if I hook up and I see the voltage is coming off the panel. It's around 22 volts for the 36 cell panel. The temperature, the hotter the solar panel gets, the more the voltage drops. It's about 18 volts, perfect conditions. I was trying to do a calculation here to talk about, there's something called a temperature coefficient. For every degree above Celsius, you will have a certain amount of a drop. And the temperature of the solar panel was designed at 25 degrees Celsius. So if I have a 95-degree day and I'm in direct sunlight's about 20 degrees Celsius hotter. I could have 55 degrees Celsius hotter than the rating that was stamped on the back, that 25 degrees Celsius. So this looks like a lot of math, but basically it's going to drop down probably close to about 2 volts. Then there's a power efficiency coefficient. So for every degree Celsius above 25 degrees Celsius, my solar panel loses efficiency by about 0.44%. So I'd have about 13.2% less power on that 95-degree day. Okay, good news. The intensity doesn't have a lot of impact on the voltage. The intensity of the light, how bright. So if I have low light conditions with a solar panel, the low light will mean less amperage, but if I drop 80% in illumination, I've only dropped my voltage by 10%. Now that means something on a cloudy day. Because suddenly my intensities drop down. My radio on receive might need 0.2, 0.3 amps, and if I do low transmit, if I can get a little bit of power on a cloudy day and I have a really good antenna, I can keep going and doing some good. Okay, so the ISC, how would you, if you were looking at a used solar panel, I wanted to just quickly demonstrate. Now last year I had a room with sunlight and we actually could do a live reading, but can't do that. Okay, so here's a VOM, volt-ohm meter, and you're going to take the plug here and I'm going to put it in the 10 amp spot right here. Okay, I'm going to set this to amps. Now what I have to be careful is, this is DC voltage. Do I want to direct connect that? I don't want to do my arc welding today. I don't want to do arc welding 101. So ham radio operators, we're very careful, we're cautious, and we're good role models on how to do proper things. Right? Okay, you're listening. Okay, so what I could do is I could cover the cell panel, hook it up, take it back, and see what the short circuit amps are on this solar panel. I'd check the nameplate on the back. This is a 40-watt panel. It says max amps is 2.35. I get 2.2 all day long in full sun. And this panel is well over 15 years. It's probably close to 20-some years old. So it's got an older label there.
So how are you connected?
So I'm going to hook the positive and the negative. What I'm going to do is shade the panel.
Okay.
So take away the brightness. and then let it see, and then disconnect. But you can get some rather impressive sparks with DC under load. You do not want to do DC. Now, if you have an Anderson power pole connector, you can do full load up to 250 connections or no load up to 100,000 connections. But we're not doing Anderson power pole connectors. Okay. This was just some more information. You do want to try to keep your panel cool if possible. The hotter the panel gets, the less voltage. Now, I was at Oregon Star Party a few years back in Grant County, Oregon, and I had a 65-watt solar panel with a 100 amp hour battery, and I was having fun doing Pactor 3 email connections to Europe. And this was a lot of fun, but I just propped it up like this. But I was being a little dangerous because in the afternoon, if a little wind comes up, there goes my solar panel. Now, it's made to handle a hailstorm, but I don't want to test it too much because I've spent some money on it. This is a repeater site, and what you're going to notice is they're going to have this year-round. They're going to have it facing more towards the low sun in the winter and better snow load, taking care of the snow coming off. But you notice they don't have a lot of obstruction behind the back. You want to keep your panels cool. Now, if I lay a whole bunch of solar panels on the ground on a really hot day, am I going to get the best performance? No. If you said no, you understand exactly what was happening very well. So if I lay it on top of my trailer, I might not get as much, but I have to, if you mount it on something, give it some room up a little bit so some ventilation can happen. This is that California condition thing I was talking about. I don't have time to go through that. A sun hour. If I had a bucket in noontime, 30 minutes before, 30 minutes after, and I was able to collect all the energy from 11:30 to 12:30, if 12 noon is local, high sun, that would be 1 sun hour. About 1,000 watts or 1 kilowatt. A lot of people like to talk about sun hours, and this is just showing the United States, what kind of solar intensity do you have in your neighborhood. If you're from outside the US, you've got a different chart you're going to look at. Now, the angle that I place the solar panel, here it is. So a question people are going to have is, okay, Mark, the sun moves, my solar panel doesn't. When do I have to move it? Well, depending on what you want to do, if the sun is traveling across the sky, you want to go a little bit ahead, come straight on and a little beyond. And I have a slide here that's going to show what happened. So I angled this solar panel direct in the sun was giving me 2.3 amps. It's rated for 2.35. It's not doing too bad. Angled it 15 degrees off, 2.23 amps. 20 degrees off, 2.19. Angled it off 30 degrees from the sun, I got 2 amps. So go 30, let it go straight, go 30, about every 30 degrees. This happens to be over in Wheeler County. We're doing a little demonstration, and that's a 65-watt solar panel. Just kind of throwing that out there. It can be close, propped up, but what I should have put in this picture is something to hold on to it if you had any wind. This is my dad's Airstream. He sold it now, but he was enjoying putting solar panels on top, and then he had one extra 75-watt panel he put behind the seat inside. So if he parked somewhere where there's shade, he could then take his 75-watt and get something. He's getting something if he's not as good with these two, I think, 85 watts. And then he could chase with a 30-foot cable the ideal sun when he was having fun with his RV. That's just another picture there. Now, sunlight intensity over a mostly sunny day. This is a slide that I got. Just want to show that. Now, this slide here is the maximum PowerPoint slide that kind of shows if the energy from my solar panel right about in here is where I want to be. And there's a charge controller that I'll show you today that can kind of keep you in this spot. So here's 1,000 watts per square meter, giving you, 7.5 amps maybe. If it's 800 watts, so this intensity drops my amperage, there's 4 amps, there's 2 amps, and then the voltage shifts, the temperature shifts the voltage. Okay, 3 major types of solar panels. There's the monocrystalline, polycrystalline, and the thin film amorphous, aka Harbor Freight. Okay, so 100-watt monocrystalline solar panel. The silicone material, they're very efficient. The big commercial ones, they have a 25-year warranty to have at least 80%, a lot of them, and 10-year workmanship warranty. And the panels from the 1970s are still putting out power. These solar panels that I have here will put out power when I'm, there's a little headstone. Okay, now solar panels don't do well in shading. There is some bypass diodes that they put in, and you don't want them to get too dirty, but you want to keep them in clean, full sun. Polycrystalline, they kind of melted it. Oh, and they're the best ones to get. They're an excellent choice for portable power. The polycrystalline is slightly less efficient. They mix and put it together. Here's an example of my dad's 75-watt polycrystalline. So he used that to get his ideal sun if he got to the campground and all the sunny spots were taken. He'd at least still get something. And then you just have to use a separate charge controller on that when he did it to the battery. You can use more than one per solar panel. Okay, and there was the label. Thin film. Here is thin film. Now what I'm going to show you, this is a 40-watt solar panel. How many watt do you think the thin film is?
15.
It is, because it says it, right? No? You know it already because, yeah. Right. Yeah. Do you see a difference?
What's the wattage difference?
Well, this is a 15 watt and this is a 40 watt.
Okay.
Yeah, so this one's heavy, the thin film. Now, you can have some fun with thin film, but just recognize that for portable operations, you're going to have a lot more weight for less joy. So now, I went into Harbor Freight. They have the thin films there. Here's a 25 watt. And the reason I put this slide on here is because it says 66% more power. Now, if you were new to solar and somebody told you, this is the panel to get, it has 66% more power, the problem was I checked everywhere. I couldn't find 66% more power than what?
Then their older one.
Must be. Okay, so amorphous is okay if you're not moving them around. You don't get as much joy as you're doing this for fun. It's for the consumer market, the thin film. They do have a little less power loss above 25 degrees Celsius. Now, solar panel efficiency, think very expensive. Those satellites, they got multi-junction. Here's a slide that I used like 2 years ago. This is talking about the different technologies. Unfortunately, these ones on the higher part, they're out of the amateur radio budget. Okay? So I want to stick to something that you might possibly enjoy. So monocrystalline solar efficiency is about 15 to 22%. Poly is about 12 to 18. And the thin film over there, about 7 to 14. And then when you talk about efficiency, they're either talking about solar cell or the whole panel. There's a little difference.
I'm confused. Which one would actually be better?
Monocrystalline. The monocrystalline is got the reputation. They've been around since the 70s. Still putting out power a little bit less, but they're going to keep going for you. They're well-proven technology. So this is just talking about open circuit voltage. A 12 volt is 22. A 24 nominal 24 volt panel is your 72 cell. Okay, grid tie panels. They have up to around the 60 cell panels might be around 20 volts. Each cell, okay, basically I'm just trying to say something about that it's 0.5 volts per cell, and they're going to put it in series. So now let's say I want more power. If I want more power, I can parallel panels and I don't have to have them be the exact same thing. So I can take this here, turn this around. Now I actually took off the MC4 connectors and put Anderson power pole. I might not do that again knowing what I know now. I was just, I was learning. So if I want to get more power, I can take different solar panels. These are all off-grid 36 cell. So I've got 36 cell panels. I'm going to just plug this in. And if I had another solar panel, I could plug that in. Now, if I parallel these solar panels, there's an example on the back. I can just use a distribution block. I've connected them all together. The solar array will be the sum of all the amps. So let's say I had 1 amp here, 5.5 amps, and 2 amps. I just add them all up. But what I have to know is the array voltage will be drawn down to whatever the lowest voltage panel in that circuit. That doesn't make a lot of difference with pulse width modulation. It makes a huge difference with MPPT charge controllers that go through a transformer. And I'll talk about that a little bit. Okay. Now, you can also take solar panels and connect them in series, but now you're stepping up the voltage, and you're going beyond my education as just a solar enthusiast. So be careful. You might get past what is safe contact for human contact. Anderson power poles are pretty helpful that way to not get hurt. But if you do that, be aware that you're getting some high voltages. If I parallel two 100-watt panels and I run them through an MPPT charge controller, I've got higher voltage, so I have a little less drop in amperage on my cable that goes outside to the solar panels, and hopefully I'm not in the sun. I'm up to maybe 30 feet away or so. Solar panel shading. Solar panels do not like to be shaded. I had some slides, but I just didn't have time to put them in. If I just go like this, I knock the output considerably. So you do not want to have things, and at the bottom, if you're in a field, you do not want blades of grass coming up. So what I do is I'll have like something I'll put down or a little board or something, put that on, prop back. Now, this is some pictures from Portland, Oregon at one of the homeless camps where they were helping out with tiny houses. And I want you to see if you see any shading going on here. You see any shading? Any more shading? Is there any shading?
You have an angle problem too.
Yes, yes. It may be that they didn't have any choice. A volunteer set them up, but they weren't getting as much joy. And if they had a bigger budget, they could have maybe got a little more in the clear. So most of your off-grid solar panels, okay, so what we want is up to about 140 watts. Ideal choice about 40 to 100. Some of the solar panels will be hinged. Okay, I'm going to come right over here. Just like this, I pull back the legs, and here I am. This is the best solar, I love this solar panel. This is the 120 watt Bioeno Power solar panel, monocrystalline, and it parallels in, and it gives you for Anderson power pole connector. I hook this up in full sun with the battery that goes in there with a charge controller. And if the temperature is not too hot, I'm getting 9 amps. I can have a lot of joy with 9 amps. I can do a lot of transmitting with 9 amps.
How much does the pocketbook hurt on this?
About $220. Okay, so if you're buying a used solar panel, you want to know, am I getting something good or not? So you can take this, let's say you were looking this solar panel over. Excuse me for a moment. you're checking it out. So I would check its open circuit voltage, hook up and find the voltage in good sun, and realize that I might get a little bit different value if it stayed in the sun for 15 to 20 minutes, because if I heat the panel up, it's going to drop down some, so be aware of that. And the other thing is I can do the short circuit amps with a VOM. Make sure you put the connector over for amps. And then I want to look it over, and do I see any moisture? You know, hit it with some water. It's made to go outside. So hey, I'm interested in your solar panel, but I want to hit it with some water. Or, I mean, just do anything you can to look it over. But this solar panel here is going to keep going and going. Is that the Energizers or Bunny? Yeah. And that's a monocrystalline. Okay. One solar panel that is really nice is the Siemens 75 watt. They were very popular at communication sites. The communication sites upgraded, and they surplused out a lot of those. I used to have one of them or more. And just ask the questions like, why did you take the solar panel out of service? Was it an upgrade? Were you having a problem? What was going on? Decide on how much wattage you want. And like I said, look at the maximum power. And then note the average price that you would normally expect to pay if you're new and you're not sure. But beware, somebody might try to sell you a solar panel for a price that seems too good to be real. Now, as I was looking over the internet, I don't want to say anything wrong here, but I kept reading about something called the Mighty Max solar panel and some very unhappy reviews. And my amateur radio friends, I don't want you to be one of those people writing a bad review. So they want to sell the 100 watt panel for $85. Do you see a problem with that? It might be a quality problem. I don't know for sure, so that's all I should say. Now, Hawaii is looking at solar and actually has a very large solar array. And what people are doing more is they're doing solar with LFP as the storage.